Hello guys, you're welcome back to part 2 of our discussions on solving of business statistics MCQs. So if you are new on this channel, please consider to give the video a like. It's very important that you give the video a like so that we can get more engagement on this video. That is when the YouTube will push the videos to other students also to get the benefit of this video. So please like the video and then subscribe if you haven't subscribed, so that anytime we release any video, you'll be the first person to get notified. So without wasting my time, let's go straight away to part 2 of our business statistics MCQs that we are solving. Alright. So as we started in a previous video, I've given a link in the description section of this video. You can check. We had the first part where we had our questions from question 1 to question 20. So we are just continuing like that in that form. So this is going to be the first question for this video. That's question 21. So you can check the links. You can check the description section of this video. I've given the links there. You can check and watch that video too, so that you get to understand it better in our journey to solving some of the questions on statistics or business statistics in that case. So let's move on straight away to question 21. Here's how it goes. Which of the following is not a measure of central tendency? We have already established that central tendency helps us to know the center of what the data. So once we know that measures of central tendency tells about the center of what the data, we have 5 kinds or 5 elements of measures of central tendency. We have the first one, which is the mode. The second one is the mean. The third, which is the arithmetic mean, the weighted mean, and then geometric mean as part of it. So we would have 5: the mode, the median, and the mean, which is breaking into 3 sections, which is the arithmetic mean, the weighted mean, and the geometric mean. So looking at these options, so we can clearly see that the one that is not part of these measures of central tendency is the mean deviation, which is the D part. So it is D where it's not part, but mean deviation is an element of a measures of dispersion, where we talk about the spread of data. So mean deviation is certainly going to be out of the measures of dispersion in this question, because mean deviation is one of the elements of measures of dispersion where we talk about the spread or the variability of data. So the answer is D in that case. And as already indicated, I made this indication that at the end of the day, you pause the video. Any question that we journey on, you pause the video, then you provide your answer. Okay, after that you resume the video to know whether you had your answer right or wrong. And at the end of the day, I'm expecting you to comment your marks that you obtain from this MCQ in the comment section to know how well you perform, so that in future you know how to strategize and know how to go about your learning activities. Okay, so at the end of the day, put your marks that you obtain from this MCQ that you are solving in the comment section, or your marks, so that I know your performance in this case. Okay, so let's continue. So that's mean deviation. So question 22 in this case for the part 2. Use the information below to answer question 22 and 24. So that's what you're going to use to solve in this case. So the mark score in an examination by some students are given in a table. So we have from 0 to 11 as a max, then the frequency is from 0 to 2. Okay, that's various frequencies for the various marks in that case. So we are asked to calculate the mean of the distribution. And when you're given this kind of question, you see under the condition of examination, when you're under examination condition, you have time that's allotted for each question to be solved. So here you need to be very fast and know how to use your calculator, Casio FS 991EX. That is what I'm talking about here. So instead of you by going by the manual way where you'll be multiplying the frequency by the various marks and summing all of them up and divide by the total frequency, you can use a calculator to solve it actually. So that one is also there. So to solve this question using a cash calculator, first of all, you take a cash calculator, you go to identify we have where the shift is. You press the shift and then you press onto the mode. After pressing on, you see the screen will appear where you have a set of options. Just use the arrow to press down the downward arrow and then it will bring you to another set of options where we have 1, 2, 3, 4, 5 and 6. You press the 4, which is the start, so that you turn on the frequency table on. So once you press the start, which is the 4, it will give you an option, frequency on or off. Then you select the one which is on. So once you on it, that is what then you come back to. It will take you to the home screen of your calculator, which is a Casio 991EX. Right, so after that, you locate the mode once again, then you select 3, which is the start. After selecting the 3, then you select 1 in that case, and then you actually key in the values. You get on the screen, it will appear X and then frequency. X, you have X column and you have frequency column. You just key in these values that you see here, these values I'm talking about. Keying for X and keying for the frequency. So the X is going to be the max, and then the frequency is going to be what you're going to provide in the frequency section on your calculator. So you turn the frequency on. Okay. So after keying in these values, okay, the next thing that you need to do is to press AC on your Casio calculator. Then you locate the shift again, where the shift button is. You press the shift and you press 1 on your calculator, and you see that a set of options will appear where you have type, data, sum, var and other information is there. You select 4, and once you select 4, that's the var, you're going to have another set of options where you have 1, which is n, the second one which is x bar, the third which is the standard deviation symbol, then the 4 is also another symbol. So you're looking for the mean, so you select the 2 and the x bar will appear on the screen. Then you press equal to sign, then you get your answer in that case. So that's how we use a Casio calculator to solve actually. Okay, so that's what you're going to do in that case. So please follow the guideline I'm giving you if you have any set of questions like this, so that you won't waste my time in using manual way to calculate it. But in this video, I just use the manual way to calculate it for you. So when you are in the condition of examination, you must make sure you use your calculator very well so that you can save time and then move on in that case. So it's very important. So let's see how the presentation and solution of the mean was done. So as I said, if you want to do it manually, all that you need to do is to look for, we said mean is always what? In this case, a group frequency, summation f of x over summation f. So you are going to multiply the marks by the relative frequencies for each max. Okay, and after that, you sum all of them up as I've done here. You sum all of them up. You also sum up all the frequencies in this case. So you sum up all after multiplying the mass and the frequencies, and then you do the summation of the frequencies and you cause the division between the two. So when I sum up my summation f of s, I had 1437, then the frequency, total frequency was 283. So the division results in, so you see the division will then result to 1437 over 283. Then I'll get in 5.077. Then based on the options, it was terminated to 1 decimal place. So I just converted to 1 decimal place, so it becomes 5.1, and that was the option C in that case. So option C, which was 5.1. So that's how we derive it. But as I've informed you, you're an examination condition, make sure you use calculator and then you work it out so that you can save time, right? Then 23, because we said we should use that information source for 22 to 24, so mean that 23 will fall within the median of what the distribution. So to calculate the median of the distribution, we said it is actually the middle value of what that set of data. So all that you need to do here is to find out the total frequency, and in this case we said the total frequency was what 283. Okay, the frequency was 283. So since this 283 is an odd number, for you to find the median, you need to add 1, so it becomes what? Half each bracket n plus 1, and the n represent the frequency, so you're going to be 1/284, and that's going to give you 142. And because this a frequency in a tabular form, though it's an ungrouped data, but then in a frequency table form, we are going to use this to locate the position of the frequency in this case. And most of the times it's based on the option that you're going to, as we have the options here, we have the 7, 6, 5 and then 4. These are the max. So after you're able to know the position of the median, then you can easily go on to identify. So let's see how it was solved in this case. So as I said, if the summation is odd, here is also odd, that's double D, odd, not odd. So take note. Then you need to add 1 to it, but then if it is an even number, then you need to maintain it and divide by what? Half. So median, we're talking about 50% of what? The data. The value of data at the middle, the middle value, or that's what we mean by what? Median. So as I'm saying, once you're able to have that 50% of the middle value, that will be your position. So here we had what? 142 as our middle hot value. So after that, you go back to the data. So you go back to the data. So let's use this one. So you go back to the data. So you ask yourself, if I should start from the frequency of 0, and if I should add, what values within the frequency that I should add in an ascending order in this form, what I should add, that will fetch me 142, and is on which max. So once you're able to know that, then you can determine what? The median. So you can clearly see that we have what? 142. So 142, if I add 0 to 16, I'm going to get 16. I won't get to 142. Plus 27 to it won't fetch me 142. Plus 37, it won't fetch me what? 142. So as I was saying, add 0 plus 16 plus 27 plus 37 plus 46. Even with that, you get a value that is less than what? 142 as our position. So meaning that the median will fall within a max of what? 5. Oh yes, at the frequency, when you add the frequency of 36 to this, so this is what I'm trying to talk about. When we add all these values in there, that will fetch us what? 142, and in that, once you get that 142, it maxes what? 5. Where you had 142 will be what? 5, as I've indicated the arrow at the top there. Then you get that. So that is the median in that case. But then if we were to be an ungrouped data, like let's say 1, 2, 3, 4, or let's say any data values, let's say 5, 7, 2, 1, 4, all that you need to do is to arrange them in ascending order, and then you, based on the set of data, so if the total number is, let's say, 5, then it means that you are going to arrange them in order, then you determine the median, which is the center of that data. If it is an odd number, then you add 1, so that you use your half of n plus 1 to determine the position, so that you're able to know the median in that case. Because here is an ungrouped data, but then it's in the frequency form. You need to add the frequency. You need to add up the frequency. That will fetch you what? 142. And in that case, realize that it was 0, 16, 27, 37, 46, and 36. That will fetch us for the 142. And it falls on the marks of what? 5, as I've indicated. In that case, so that is the median. So let's take note of that. I hope you are following and you are getting it right, okay? So try to accumulate your mass that you are getting in that case. So that is the median, by the way. So you see we had what? 5 as an option or the answer in that case. So take note. So you're asked to find the mode. You said the mode is actually the number that occurs most, or the frequency of a value in a data that occurred what? The most. Alright, so that is common to the data. So let's see, let's go back. You can clearly see that here which frequency or which mass has the highest frequency, and you can see that is what? 46, and the mass is what? 4. Right? It's 4. 46 has the highest frequency and the mass is what? 4. So you can say that the mode is what? On the mass of what? 4. So that is the mode. That's why we determine mode from long group data. So let's take note. So mode is what? 4. So that is the answer in this case. So let's take note. So as I was saying, it's 46 in that case. So we can read. Then 25. In a country P, the coefficient of variation for salaries of trainee accountant is 40%, whilst in country Q it is 60%. Which of the following statement can be made on the basis of this information? Places this, not this, so the X part will be cancelled in the information. Right. A. In P, 40% of trainee accountants have below average salary. In Q, the lowest salary of trainee accountants is 60%. C. Salaries of trainee accountants are more variable in Q than in P. D. Then salaries of trainee accountants are high on average in Q than in P in that case. Okay, so here when you're talking about coefficient of variation, you're saying there's one of the measures of dispersion that help us to know the spread of variability of our data. Right? Variability of data from what it means. So let me use that in that case. So here, when you have high coefficient of variation, meaning that the standard deviation value they're going to determine, if it is high, then if it's high or is very far from the mean, then there's more variability in that set of data. But then if the standard deviation is close to the mean, then the variability is very low. So you can clearly see that here, these are the variabilities. We're having what? 40% and then 60%. That's for P and then Q. You can clearly see that when you have 40 and then 60, which of them will be more variable from the mean? It's certainly going to be 60, because 60 is what? High value, and going to be far from what? The mean. So the variability or the spread from the mean is going to be very high. So in that case, we are going to go by an option of option C, because the option C says that salary of training accountant are more variable in Q, that is 60%, than what? In P. So that is the coefficient of what? The variation. Okay, that helps us to know how the standard value or the standard deviation value is, whether further away from the mean or close to the mean. And most of the time we use this in an investment purpose. In business science, we use it for investment purposes. If you want to know that this particular investment undertaking is of high returns and the level of risk is whether high or low, based on this coefficient of variation you can determine. So if you have high standard deviation, then it's certainly that investment there's higher risk. But if you have low standard deviation, then it's certainly that investment you have for lower risk and you're going to be close to the mean. Alright, so it's actually coefficient of variation that will tell you, or that informs you whether you should go by accepting this investment decision that you're making, or you shouldn't accept. So it's very important in the sense of business when these tools are employed. So that is one thing about coefficients of variation. So here the option is what? Option C as our answer, and I hope you had it. So if you are getting it right, comment below in the comment section. Let me know whether you are getting the concepts right. Okay, right. Then 26. If two events A and B are statically independent, the occurrence of A implies that the probability of B occurring will be. So if we said that statically independent events, I've made a video. They are all in the description section of this video. You can check the links. It is there. We said two events are statically independent if the occurrence of one has no influence on the occurrence of the other. So meaning that if A occurs, it won't affect the chance of B occurring. So meaning that B can also occur and A can also occur. So means that the probability of B also occurring won't change. It will occur. So it won't change. So that will be the option, and not 0 and not 1, no, not unknown. So if A occur, meaning that B also occur, so the probability of B occurring won't change. So that's going to be the answer in that case. So B occurring will be unchanged. So that is one thing they need to know. Right. Then you have another set of data. Use the frequency distribution table to answer question 27 to 30. So that's why we have in here. So 27, we are asked to find the lower quartile of the distribution. To find the lower quartile of the distribution, here is a group data. You know, you should use a formula. So lower quartile, that is the first quartile, which is L. LK of 1 should always go to LQ plus your N over 4. My board is very small. So LQ of 1, your LQ plus my N over 4 minus my frequency capital and my frequency of the lower quartile, all multiplied by C. That's the class width. Okay, good. So this will be the formula that's going to help you, because it's a frequency, a group data. So you're going to use this formula, and actually I'm going to explain the variable within this formula. So let's see how it was solved here. So here, this LQ, the small LQ, is actually the value of what, or the lower boundary of the quartile class. So the quartile class, in this case, our total frequency was what, 75. So for you to determine the quartile frequency, it is actually 75 out of what, 4, and that is going to give you 18.75. I think so, 18.75. So once you're able to know, so it means that 18.75 is going to be in this class, the one I've indicated with red, because 18, 17, 14, then 18 going to fall within that class. So once you have that value there, then we are going to work your way around with that class. So that LQ here, this LQ here I've indicated here, it is a lower class boundary limit. So in this case, it's going to be what, 1.95. And the reason why you're having the same thing as the original question is that here, if you want to calculate the class boundary, we say class boundary is the upper class of any, the upper limits of any class compared with the succeeding class. So you clarify that when I take the first class, second class, you see I have 1.95 here. I also have what, 1.95 here. When I take the difference, it's 0. So 0 divided by 2 going to 0. So it's going to not be affected by the upper and lower. It's going to be the same. So that's why you still have what, there, 1.5 there. I hope that is clear. Because for you to find your class band, you must first of all find the difference between, so that you know which values to be added to the lower class, subtracted from the lower class limit and added to the upper class limit. So once you do that, then you do manipulate. But then when you do that, which is 1 point, so that's what I'm saying. When you compare the upper class limits of any class with the succeeding class, you're going to with the lower succeeding class, the lower limits of succeeding class, it's going to get 0, so it's not going to have any effect on the class boundary. So the class boundary for the original question, that was the length of time, going to be the same as the class boundary, so it won't change. So that's why we had that 1.95. So that is the lower class boundary of the quartile class. Okay, then the n over 4 here, the n over 4 here would determine your quartile position. So that was what we had. We said it is 75 out of 4. So it is a frequency, that is a 75 divided by 4. And then the f here, this f is actually also your cumulative frequency before the quartile class. What would be the cumulative frequency before the quartile class? That was what? 14. Because the quartile class is what? This class. Okay, so before the class, the cumulative frequency is what? 14. So that's why we had the 14 here. And then this f here is the frequency of the quartile class, and that was what? 27. So when you manipulate, after all, you should be able to arrive at your, and the c here is your class width. We said class width is the difference between the upper class boundary limit and the lower class boundary limit of a particular class. So in this case, it's going to be 2.95. Here I'm talking about 2.95 minus 1.15. I'm going to give you what? A 1. And when you multiply, then, so when you manipulate all these results, you should be able to arrive at what? 2.1259. And when you convert to, based on the options, is 2 decimal places. So convert to 2 decimal places and get what? 2.13. So as 2. What? So here they're having a 2.12, but then it's the same thing. They are very close. So the option A still what holds. So let's take note of that. So that's the same they're going to apply when you are doing, let's say, the median of the quartile, the upper quartile. The same thing is going to apply. So take note. So they're asking you the median of the distribution, which is what? Half of the distribution, right? So half of what? 75. So it's always going to use the same formula approach, but just that you're going to be doing the substitution here. You're going to be n over 2 instead of the one that we have n over 4. That's the lower quartile. The lower quartile was 1 over 4, and here is the median, the middle value. So it's going to be what? Half, or the 50% of it. Okay. So let's see how they also conducted that in that case. So the same thing. This value was there. So the only thing that will change is this. Because of the only thing that will change is this, because of the median, because you are finding what? The median of the distribution from a group data. So if you count 75 over 2, then the rest will still remains the same. So that's why when you do the manipulation or the calculation, you're going to get what? 2.82 in that case. So you see they're going to arrive at 2.82. And let's see the options here. So we have 3.43, 2.44, 4.82, then 2.82. Selling the D is going to be what? The answer in that case. So let's take note of that. So option D is here. Then the upper quartile is going to be 3 over what? 4. That is 75% of the data set to determine the position, right? So the same thing is going to be here. As I've indicated here, it's going to be what? N to bracket multiplied by 3 over 4, and that's what we are having here. As I've indicated, 3 over 4 multiplied by the frequency of 75, and then other things. But here it will actually, the reason why I made this illustration here is that the median is that the median value for the set of data was within the second class limit, right? So the second class interval rather. So that's why we are still having this 1.5 here. But then the upper quartile, which is the 3/4, will fetch you something like 56.25 or 26 or something like that. So index is going to change. The class is going to change. 14 plus 27 is going to give you something like 41, plus 14 will be something like 55, like that. So it says it's going to be within this class for the upper quartile, and that is why we're having the LQ to be 3.95. And then when this one is going to change, the F will change, and that of the frequency of the small f, because we have already explained these things, that the F, capital F, is the frequency before the cumulative frequency before the class boundary or the class limits of the quartile class, and then the small f is the frequency of that class, the quartile class in that case. So that's why you have the 10 here. This is the 10. Okay, so let's take it. When you do the manipulation, you're going to get 4.075, and that's option what? D. Option D. So they had here to be 4.08, but then the same thing. Okay. Then third C, you asked to find the mode. So to find the mode, we said to find the mode. Mode is actually calculated as. So this is how we calculate what the mode. The LM means the lower class limit or lower class boundary of the mode class. Okay, and then this one. So the LM is the lower class limit of the modal class. Then this is the first triangle. 1 is the frequency before the modal class, and then triangle 2 is the frequencies after the modal class, the summation of all frequencies after the modal class. And C always remains the class width in that case. So let's see in this case. So here we can clearly see that the class with the highest frequency, that's the mode, was what? 27. So the modal class is going to be what? This. Okay, so that's why you see the 1.5 there. So the 14, as I explained, for the first triangle, and the second triangle is the summation of all the frequencies after the modal class, and then multiply by your class width in that case. So after one minute, we're going to get what? 2.24, and then we're going to get you option what? A. So 2.24 was what? Option A. So that is the answer to that. So I hope you are enjoying, right? So if you are getting it right, comment below, and make sure, as I said, you pause the video, you solve it before you look at the approach that I used to make the solution. So let's continue. Then we have question 31. A sample of experienced data entry clerks that their mean typing speed is what? 87 words per minute, and median is what? 73. The standard deviation was 16.9 words per minute. What is the coefficient of? We say coefficient of skewness. Coefficient of skewness is calculated as 3 multiplied by the mean minus the median, okay, or divided by standard deviation. Standard deviation was the value. So that is that. Then you substitute the words in there and you get the coefficient of skewness. So that is another way of determining the spread of our data. So when you manipulate, you're going to get what? 2.49 in that case. So that will be an option what? C. Option C. So let's take note of that. So it's always 3 bracket mean minus median or divided by the standard deviation. So keep this formula, please. Keep it. Then anytime you see coefficient of, that's what we are talking about in that case. Then question 32. If probability of A is equal to probability of A bar B or bracket close, the events A and B are. So let's analyze this. So if I have probability of A and there's a probability of A going to probability of what? A slash B. Okay, then what is happening here? They're saying A is mutually exclusive, B exhaustive, statically independent, then dependent. So let's see which of them satisfy this rule. Okay, we say mutually exclusive. When you have mutually exclusive event, means that the occurrence of A will exclude B occurring, then the occurrence of B will also exclude A occurring. So in that, it's going to be A or what? B. So A or B will establish the addition law with probability of A plus probability of what? B. How that is clear. Alright, so here it won't satisfy. So mutual exclusive is out. Then exhaustive, you are saying the exhaustive for probability of A and or B occurring should be equal to the sample space, and in that it becomes probability of A union B going to be the sample space. So here it is also not satisfying this. Sorry, there's also out. It's also out. When you talk about the statistical, we are saying that two events are said statically independent if the occurrence of one does not have influence or effect on the occurrence of the other, meaning that both of them can occur at the same time. So if that is so, then we are saying the probability of A and B occurring at the same time will lead us to our multiplication. How are you going to probability of what? A multiplied by probability of what? B. Okay. So in that, I can say that here it is probability of A and means or intersection, probability of what? B. And that is so. Okay, so after that, since you're able to get this as your statistical independent, then we can say that if I to make probability of A the subject, I'm going to divide both sides by what? Probability of what? B. Okay, when I divide both sides by probability of B, you remember that this becomes more like a conditional probability. Have you seen this? You remember that it becomes something like this. So the one I've indicated with the circle, you can clearly say that if I divide both sides by probability of B, I'm going to have P into bracket A intersection B bracket close all over probability of B. And have you seen this? It looks like what's a conditional probability. And you said if that is so, then means that probability of A is the same thing as probability of what? A slash what? B. Okay, A slash what? B. And then we said in that it's going to give you probability of A intersection B all over probability of what? B, because the idea is that for A to occur, B should already have not occurred. So if this condition satisfies two events, then you are saying that such events are statically what? Independent. So that's what we mean by statically independent events. So the answer is what? C in that case. They're not dependent in that case too. So let's take note. C. So let's move on. Question 33. When a meteorologist says there is 30% chance of showers, what type of probability is the person using? So here, can clearly see I've explained deeply a lot about this probability. They are all in the description section of this video. The links are there. Part 1 of probability, you can see I give a detailed explanation about these things. So here the option is what? C, subjective what? Approach or subjective view approach, right? Because there is no what? Information that is using to make that estimation or that prediction. So it becomes subjective, right? So let's take note of that. Not classical, neither empirical or relative. I hope that is clear. So if you are getting it right, comment below. Please make sure to like this video so that you can get more engagement on this video. Like and like and like, alright? Please like it, continue to like this video, it's very important. Alright, so let's continue. Question 34. Which of the following is the highest level of measurement? You said, as I indicated, you have 4 levels of, you have the nominal, the ordinary, interval, and the ratio. And we are saying that out of these, the highest level of measurement is what? The ratio, because it contains all the features of the nominal, interval, and the ordinary. and in that there is an element of 0, which is what meaningful, and I've explained these things in the previous video on this business statistics question that we are solving. There was one question that actually I deeply explained it, so you can check the video in that case and then watch. So that is ratio measurement. So let's move on. We are asked to find the geometric mean. You find the geometric mean of this data. This is going to be geometric mean JM is equal to the nth root of x1 multiplied by x2 multiplied by x3 up to what final n. So that is how we find geometric what mean in that case. That's how you find geometric mean in that case. So as I've already told you, pause the video, solve it before you look at the approach that I used to make the presentation. That will help you to learn much. So take note of that. So let's move on. As I've indicated, that is the formula for find geometric mean. So you do the substitution of the values that was given in the question, these values, then you are good to go. Just multiply and take. So how many values were you having? We're having what? 1, 2, 3, 4. So 4. So the nth is going to be what? 4 foot. And when you do that, you're going to, with the help of a calculator, you should be able to arrive at what? 8.39 in that case. And I think the option was in there, 8.439. So option C as our answer. So let's move on to question 36. This is also another aspect of geometric mean. And when you are finding geometric mean of a given period of a particular item, we take into account the value of that item at the beginning, right? Compare with the value of the item at the end. So in other words, for us to know the relative importance the item has actually occurred over this period, we are going to take into account the value of the item at the end of the period. I mean, based on how that item has actually is being valued now, based on the period that it has underwent. Okay, compare with the value at the beginning of the period. But once you know the period, you just compare. So this is what I'm trying to tell you. That's why geometric mean in this case is going to be the nth root of the value at the end over the value at the beginning. Alright? So here, after that, you subtract 1 from it and multiply by what? 100. Or multiply by what? 100. Or multiply by 100%. Or 100 in that case, then you are good to go. So this is what I'm trying to tell you. Actually, reading with the question, it said production of Cablo tracks increased from 23,000 units in 1978 to 120,520 units in 1998. Find the geometric mean annual percentage increase. So you can clearly see that from 1978 to 1998 it was only 20 years. So as I've indicated, that is the formula. Value at the end of the period of value at the beginning or the start of the period minus 1 multiplied by 100. So when you do the substitution, then you get your geometric mean. It's very simple. So make sure you get it right. Then question 37. A sample of senior citizens revealed that their main annual retirement income is 16,900 Ghana cedis. Since the mean is based on sample, the 16,900 is what? 900, not 9,000. 16,900 is called. And we are saying that if we are studying a whole population, or if we are studying the whole group of people, then we are into what? Population. And population has a characteristics that is measured as what? Parameter. Alright, but then if you are studying part of the population, you are studying the sample, and the measurable characteristics of a sample is called a static. So here the answer is what? Statistics. So you're going to what? C. So here the 16,900 is what? A statistics. That's the measurable characteristics of what? A sample. Statistic is a measurable characteristics of what? A sample. And parameter is a measurable characteristics of what? A population. So take note. So the answer is what? C. Since we are dealing with a sample, take note. The value of variance can never be A positive, B 0, C larger than standard deviation, D negative. So we are saying that always the value of variance should be either positive, 0, or larger than standard deviation, but it cannot be what? Negative. If it's negative, it's impossible. So it cannot be what? Negative. So take note. A method of assigning probability which assumes that the experimental outcomes are equally likely is referred to as objective method, classical method, subjective method, and control method. Here too, I had a video on probability where I've discussed intensively about these concepts and these methods. They are all in the description section of this video, you can check. Part 1 of probability I've explained deeply, so please make time and then go through. You get all these concepts. So here, a method of assigning probability which assumes that the experimental outcomes are equally likely to happen is what we call a classical method, and not objective method or anything like that. So as I've already informed, I've kept a video that explains all these concepts, so kindly check them out. So the answer is what? Classical method in that case. So let's take note of that. Then our last set of questions for this video is question 40. A statistic that tells the number of standard deviation a data value is above or below the mean is called A quartile, B percentile, C coefficient of variation, D a z-score. We said a quartile, we are talking about divisions of 4, percentile division of hundreds, and coefficient of variation, we are talking about the spread of what? Data, right? Where we take into account the standard deviation over A to what? Arithmetic mean. But then here they are talking about a data value whose value is above or below the mean, and we call such data or such statistical technique as what? A z-score. Which actually it is what? A z-score. A z-score is actually a value that would determine whether the standard deviation is above or below the mean. And most of the time we use this in industries to know their financial status, whether they are financially viable or they are not financially viable. So if we calculate the z-score, and then let's say at the end of the day you had what? 1.8, meaning that the business is not financially viable, or it can go into bankrupt. But then if the z-score is 3 points, whether it's 3 or above 3, then it means such business is financially strong, and then they can survive for long. So that's an aspect of z-score. It will help us to know whether a business can go into bankruptcy or can continue its operation based on its financial status. That is an application side of z-score. So it's actually a statistics that tells the number of standard deviation a value of data is above or below what it means in that regard. So let's take note of that. It's very, very important. So this is where we bring an end to part 2 of our discussion on business statistics questions. So if you are new and you have watched up to this part, thank you very much. So kindly make sure to subscribe, like, and share so that you can get more engagement. So I'll see you in the part 3 of this video. Bye bye.